Okay, so Newton's method, actually very simple. This looks complicated and weird, but I promise you it's actually probably the easiest thing that we've learned. So, okay. So, take a look at this slope right here, right? So this blue arrow is some function, y equals whatever. That's the blue arrow. And this blue point right here, labeled r, that is the solution to the equation. So if you might remember this from high school or whatever. The solution to a function is where the function equals 0. So where it goes through the x-axis, and so for example, if the solution to a function, let's say it's x equals 2, then that means if you plug 2 into the equation, the y will be 0. That's the solution to the equation. So in this case, solution is r, whatever value that may be. We're trying to find it. So with Newton's method, what you can do is you pick some x value on the function. So this red point right here, x0, y0, whatever x value, right? You pick an x value. If usually in these questions, they'll give you a range of x values to choose from. Or you'll say, pick an x value between 0 and 1 or whatever. But anyways, you pick an x value and you find the tangent line to that x value. So in this case, you have this line right here, this brown line, and that's the tangent line to x0. And then you find where that tangent line intercepts with the x-axis. So in this case, it intercepts right there. And then I have this dotted line right here. And now we find a new x point, given where this tangent line intercepts, right? And then we find the tangent of this one. We find the tangent line of this point, and then we find where that new line intercepts with the x-axis. And then we find a tangent line with that x, and so on and so forth. And as you can see, these tangent lines, where they intersect with the x-axis is getting closer and closer to the actual solution, to the r point, right? So the first tangent line, it intercepts right here, which is pretty far. The second tangent line, it intercepts right here, which is already really close. It's basically right on it on this drawing. And if you kept going, eventually your tangent line would get really close to where the r value is. So that's what Newton's method does. You find a tangent line, and then you just keep finding new tangent lines with the new x values that you get, and they get closer and closer to the actual solution of the function. So in this example, we have this equation, y equals x squared minus 3x plus 1. So the first thing you're going to do is you're going to find the derivative. In this case, it's very simple, right? Power rule, power rule. Derivative is 2x minus 3. Then you're going to pick your first x value, call it x0, or x1. I like to call it x0. And I picked x value 0. Again, most likely the question will give you a range, so it might say pick a value from 0 to 1 or whatever. So in this case, I'm going to pick a value 0. And all you do is you use this little equation right here. So x1, so right now we have x0, so we want to find the next x value, x1. So in this case, x1 equals to x0, so in this case we pick 0, minus function of f of x0 divided by f prime of x0. So basically you're going to take x0, so right here, right 0, minus f of x of x0, right? So you're going to take your function, plug in 0, so x squared becomes 0 squared minus 3x minus 3 times 0 plus 1, divided by f prime of x0, or the derivative of f. So divided by 2x minus 3 with 0 plugged in. And that's it. So then you get 0 minus 1 over third, which equals to negative 1 over third. And that's all you do. And then you just do that again. So now you have this new x value. This is now your x1. So to find x2, you're just going to do the same thing, except instead of before we put in 0, now we're putting in negative 1 over 3. So negative 1 over 3 minus f of negative 1 over 3 divided by f prime of negative 1 over 3 equals all this, which is about equal to 0.24242. And you just do that again, take that value, put it in. At this point, I didn't show all the steps, but it's the exact same thing. Literally, all you do is you pick an x value, and then you just do this simple equation over and over again. So again, so I pick 0. So I do 0 minus f of 0 divided by f prime of 0. And then I get a number. Then I do that. So I got negative 1 over 3. I do negative 1 over 3 minus f of negative 1 over 3 divided by f prime of negative 1 over 3. And you do that over and over again until you get a number that's very close to the actual solution of the function. You know you're close. Two things happen. For one, your x values like barely change, right? So here you can see x4 is equal to 0.38194. x5 is equal to 0.38197. Those are really close, right? They're nearly identical. And also the way you can tell is when this number at the top gets really close to 0. So in this case, it's 0.00005. That's really close to 0. And so when this gets really close to 0, you know you're getting close to the answer, because the thing is, this up here is just f of x, right? So if it's getting really close to 0, that's what we're trying to find, right? We're trying to find the value at which f of x is equal to 0. So if you're getting really close here, that means you're basically done. So in this case, took 5 iterations. Sometimes it could take more, sometimes it could take less. Sometimes you might just basically go on forever because that's just kind of how it works. This solution sucks. You know, it's good to know. It's not really helpful in practice unless you use like a computer and that can really quickly do like millions of iterations. But I guess it's good to understand, and you know, you might get a question about it on a test or whatever. So that is Newton's method.